Gentlemen and ladies, welcome to another video. In this video we're going to be learning about unconformity. Unconformity, it means something needs to confirm but it's not confirming. Guys, that's what it means, unconformity. So let's dive right into it. This is going to be a quick one. So let's give a definition for it. An unconformity is a break in geological records. This is created when rock layers are eroded or when sediments are not deposited for a very long time, which means, as we know, sedimentary rocks are formed in layers, layer after layer after layer after layer, and there is a sequence, there is a pattern, and there is a progress to the ages of the rocks. As we learn, older rocks are at the bottom, younger rocks are on the top, and then you follow the sequence all the way to the youngest rock. Now, when it's no longer sequential, when there is a missing link or when there is a missing piece of information or records, then we say there is an unconformity. For example, if this is sequence A and this is layer A, this is layer B, this is layer C, this is layer D, and then we expect layer E to be the next, but now we see layer P. So what happened to E, F, G, H, I, J? How come all of a sudden we find ourselves in P? So it means something has gone missing or something was pushed away. So that's what an unconformity is. It's simply a break, a break in geological records. It's a period where sediments are not deposited, or those sediments were deposited but were eroded away, were taken away, such that some layers of rocks are missing. To further buttress that point, this video is just going to do a little bit of justice to it. So I'm going to pause and explain as we go on. So first off, as we know, sedimentary rocks are laid down in layers, layer after layer. All right, so you have this being deposited. So there's deposition, there is deposition, and there's deposition. And we know how this works, right? Layer 1 is older than layer 2, and layer 2 is older than layer 4. So the sediment just keep piling up and keep piling up until there is a folding. There is plate movement or continental drift as the different crusts of the earth are moving, and they are colliding or moving towards one another. It folds and pushes it up, like we explained in our previous video. Sedimentary rocks are laid down in horizontal layers, the law of original horizontality. And then when the forces of tectonic movement or continental movement comes in, it pushes it and makes it to fold. And that is what is going on right here. So there is that folding due to tectonic movement. Then after that folding, whatever part of the sedimentary rock that has stuck its head above water gradually begins to erode. As you can see, different rivers formed on top as the rain falls, as the sun shines, and snow and different. So that part of the earth is exposed to the weather. So there is weathering, there's breaking down of that rock, and over time sediments begin to erode away and begin to erode, and then before you know it, it's completely cut out and eroded away. So after that erosion, there is subsidence, which means that part of the earth sinks back into the bottom of the ocean or sinks back below sea level, and water begins to gather on top again. And then once water is on top, new sediments begins to form on top of it. So a lot of new sediments begin to form on top of it. So that region, that squiggly line, that wavy line represents the unconformity, showing that this layer is supposed to be continuous, but it has been eroded away. This layer is supposed to be continuous, but is eroded away. So all of that squiggly line represents a period of no records, or the records or the deposits that were made have been taken away, eroded away. It's no longer conforming, hence the name unconformity. All right, does that make sense? Yeah. Okay, so I think that's how unconformity is formed, and once you have a grasp of that knowledge, it's easier. And this another kind of unconformity is called non-conformity, where everything is completely eroded away, and then after that complete erosion, there is subsidence sinking back to the bottom of the ocean, and then deposition begins to continue and accumulate again. A little bit of more of that in the next slide. All right, again, let's repeat that process. We know sediments are deposited at the bottom of the sea, and they're deposited in one layer after another. And then the layer at the bottom is older than the layer on top, and then that happens smoothly. And then after that, there is folding and uplifting. Folding and uplifting. Folding and uplifting. And we know what causes the folding: tectonic plate movement or continental drift. As the continents are drifting, they fold different parts of the earth, and then that part of the earth sticks its head above water, and then once its head is sticked above water, there's erosion begins to take place. They begin to cut that part that is above, is cut off and eroded and washed away. And then after that, after the erosion, there is subsidence, which means it subsides, it sinks back again to the bottom of the ocean, and then new layers are deposited on top of it. And that is how unconformity is created. This is a real life example of what an unconformity looks like. So we see that folding right there. This is a real life rock. And then we see that new sediments were not deposited on top in a horizontal manner. So definitely this region here, there's an unconformity. There's a break in records right there. So which means that part of the rock was cut off or eroded away. So in a nutshell, simply put, what causes unconformity is folding, uplifting, erosion, and subsidence. So there is folding, uplifting, erosion, and then subsidence. All right. And there are three kinds of unconformity. You have the disconformity, angular unconformity, and then non-conformity. Most times you don't get asked in the regions about the specifics of these kinds of unconformity, but for the sake of good knowledge, disconformity is when the layers below are in horizontal form, and then there is that squiggly line representing the unconformity that a layer or several layers of rocks were taken away, and then you have a new layer forming on top in a horizontal manner. So between the two layers below the unconformity and above the unconformity, they are all in horizontal form. Angular unconformity, on the other hand, you can see that it is angled. It's an angle. So it's inclined, it is tilted. The layers below the unconformity are tilted, and then the layers above the unconformity are in a horizontal line. That is angular conformity. And then non-conformity is when everything is taken away, and then there's an igneous rock at the bottom, there's a hard rock at the bottom, and then you have the sedimentary rocks being deposited in layers on top that igneous rock. That's just the difference. I hope it makes it in. All right, let's go into some regions practice question, and then we call it a wrap for the day. How about that? All right, let's go. Question number 1 here says, base your answer to the following question on your knowledge of earth science. The cross section represents 3 widely spaced rock outcrop labeled A, B, and C. Line XY represents a fault. Overturning has not occurred. So you have rock layer outcrop A, outcrop B, and outcrop C. So these are different layers of sediments that were formed. And then the main question says, which process formed the unconformity in outcrop B and C? So when you look at outcrop B and C here, the outcrop here, B and C, there's an unconformity somewhere around here. You see that? And then there's also an unconformity somewhere around there. So an unconformity again is always represented by that squiggly line. So it's asking you which processes, all right, those are the keywords, which processes form the unconformity found in outcrop B and C. As we know, it is folding, uplifting, all right, then erosion of that uplifted part, and then subsidence that makes unconformity possible. So we are looking for things around that area. So I see folding, faulting, and tilting here. Faulting and tilting are not really what is really required here. B said uplift, erosion, and deposition. Yeah, it's more like B to me. Weathering, abrasion, and igneous intrusion, no. Melting, contact metamorphism, and solidification, no. So our correct answer here is definitely B. Uplift, erosion, and deposition. All right, question number 2. Question number 2 says, which process most probably produced the irregularly shaped boundary between the limestone and shale? So if you look at the symbols here, this is the symbol for limestone and this is the symbol for shale. So we are looking at this irregular line or irregular shape here, and it's asking what process produced that irregular boundary. Again, whenever you see those unconformity wavy line, we know, going by the law of original horizontality, every rock layer should be laid on top one another perfectly horizontal, but this is not the case here. So because of this is irregular, it's asking what caused it. So once it's irregular or it's wavy or it's squiggly, we know it's an unconformity. And what causes unconformity? Definitely is erosion, uplift, and then subsidence or folding. All right, so in this case, it's definitely an erosion, telling you that there is something that ought to be there, but it was washed away, it was eroded away, it was taken away. All right, question number 3. Question number 3 says, which lettered boundary is most likely another unconformity? So we have this here that says unconformity, and then it's asking which other boundary is an unconformity. So you have boundary A, B, C, and D. Unconformity usually are represented by squiggly lines. So of all the lines A, B, C, and D, it is line C that is squiggly that best represents an unconformity. So our answer here would be C. Question number 4. Which sequence of events most likely caused the unconformity shown at the bottom of rock layer B? So we have rock layer B right here, and then it's talking about these irregular shape here, squiggly line there, and it's asking what sequence of event could have caused that unconformity. Again, we read through, we are looking for something that is around folding, uplift, erosion, and subsidence. All right, so folding, uplift, erosion, and deposition. A does sound interesting. Let's see if any other option would work. Option number B, intrusion, erosion, folding, and uplift. No, intrusion has nothing to do with unconformity. C, erosion, folding, deposition, and intrusion. No, again, intrusion is not part of it. Deposition, uplift, erosion, and folding. Yeah, it could be, but we are looking for a sequence. We are looking for a sequence, which means we should come first, we should come second, we should come third. So we can see here that option A would be a better way to go. First of all, there was folding of layer G, F, E, D, C. And then after that folding, there was an uplift. It was after that uplift that erosion eroded part of C and D away. And then there was subsidence before layer B was deposited. So in that order. So option A would be our best bet here, even though option D is correct, but the sequence is not in order. All right, last question, question number 5. Which statement best explain why rock layer 3 is missing from outcrop B? So you have outcrop A here and outcrop B here. So a layer 3 is missing. So we have layer 1 here, layer 2, layer 3, layer 4. So basically, layer 3 is missing. So between 2 and 4, 3 was eroded away. 3 was taken away. So you see 2 here is limestone, 2 here is limestone. 4 here is shale, 4 here is shale. So this sandstone layer 3 is missing. So it's represented by that squiggly line. So you see that squiggly line here between 2 and 4. So whenever you see that squiggly line, it means something ought to be there, but that thing has been taken away, and that is an unconformity. Which statement best explain why that rock layer 3 is missing from outcrop B? You have option A says a fault exists between outcrop A and B. I don't see a fault. A fault is simply a line, a crack caused by an earthquake. So that is not there right now. B says erosion created by an unconformity between rock layer 2 and 4 in outcrop B. That does sound like our answer, but let's see. Option C says a volcanic eruption destroyed rock layer 3 in outcrop B. No, volcanic erosion cannot destroy a whole layer. Option D says metamorphism of outcrop A created rock layer 3. That's not true either. So our correct answer here is B. And that's a wrap. Enjoy your holiday and see you next year.